All right, guys. In this recording, I wish to go over two examples that find not just first order derivative, but also second order derivative. Okay. The first example first. They are from homework. Okay, they're from homework. And the first one I like to work with you is x squared. Hold on. X squared plus xy plus y squared equals to 3. We want to find second order derivative. Okay, so first we're going to find first order derivative. Okay, so after first order derivative, we find, and then second order derivative. Okay. Okay, so first, of course, this means y prime, and this means y double prime. I wish you guys to see these notation as often as possible and use them as often as possible so that you can feel very familiar with them. Okay, first order derivative. So we're going to differentiate both sides. Differentiating with respect to x. Okay, you can just go ahead and get started. Okay, but I'm doing this so everybody can understand. The right hand side is 0. The left hand side, you can see we're going to differentiate 1, 2, 3, right? We have 2x plus, and this part is going to be product, right? The derivative of x is 1 times y plus, y plus x, and derivative dy dx. And then the next part is same rule, so it's going to be 2y dy dx equals to 0. Next, we're going to organize the term solving for dy dx, right? So this will be gone, remove the bracket. So these two terms have dy dx, and the other two terms do not have it. So subtract 2x, subtract y on both sides. So we're going to have minus of these on the other side. Okay, that's minus 2x minus y, right? And the left-hand side, we have x plus 2y dy dx. dy dx is factored out. And we have the right-hand side, negative 2x minus y. In the end, we have dy over dx is equals to this numerator, boom, denominator, x plus 2y, okay? So if you like, you could write it the following way. You could write it as factored out the negative sign, so remove this and turn into plus. So put a negative sign in the very front. That's okay. And now we're going to find second order derivative. Second order derivative is a derivative of first order derivative. Okay, so we differentiate the first order derivative, we get second order derivative. All right, so we're differentiating that quotient we just got, which is right here. okay? Right there. For simplicity, I would bring out the negative sign for my convenience, okay? Because if we forget the negative sign, it's a problem, right? All right, so we're gonna leave out the negative sign outside, okay? I have dy dx found, so I'm gonna continue on finding second order derivative, which is the derivative of the first order derivative. So negative sign tagging along, and we're gonna follow the quotient rule. Quotient rule, so the denominator is x plus 2y, and this denominator will be squared. On the top, we're gonna differentiate 2x plus y. So let me write it this way, okay? 2x plus y prime multiply the denominator, which is x plus 2y, okay? Subtracting, this time we're gonna keep the numerator unchanged. That's gonna be 2x plus y multiply the derivative of the denominator. Boom, okay? I hope that's clear. You want to double check this step. You do, okay? Denominator squared, differentiating the numerator, multiply the denominator, subtracting, keeping the numerator, differentiating the denominator. Okay, so we are okay. Next step, we're going to be doing the differentiation. The derivative of that part, obviously, is going to be what? I'm going to put in a bracket for my convenience, and that's going to be 2 plus y prime. Okay, dy dx. On this part, I'm going to put it in a bracket just for easy observation. That's going to give me 1 plus 2 times y prime. Okay, I can still keep them in the parentheses, but it really doesn't matter. I can just keep it in the bracket because this way it's so much easier to read. And next, I'm going to FOIL. FOIL 2 times x, that's going to be 2 times x plus 4y plus xy prime plus 2y y prime. Subtracting, let me make the font a bit larger, 300%, right? The latter part of FOIL, I'm going to put the FOIL thing in the bracket. So I'm just working on this piece, okay? So 2x times 1, that's 2x. 2x times 2y, that's 2xy, that's 4xy prime plus y plus 2 times y prime. You see, in the process of getting second order derivative, we also need first order derivative. Okay, so the next line, I'm going to apply the negative sign to each terms, right? So I'm going to drop the bracket. And so this is minus, minus, minus. Now let's see if we can reduce anything. If we can reduce anything, right? So I'm going to bring them to the next line. You can pause or just stop to see what you can get. It looks like there's some reducing we can take place. Negative 2x, take away the 2x, and 2 times y prime can take away the minus 2y prime. 4y minus y, that's going to be 3y. And here we have xy prime minus 4xy prime. So that's going to be minus 3xy prime. And then what? And then what? It looks like we're almost done, but we need to bring y prime to the picture. Okay, this is a y prime. This is y prime. And what is y prime? Y prime is this guy. Okay, so I'm copy and paste on the next line. Okay, we have a negative sign. We have all of these. And I'm going to replace y prime by its equal. I always want to do this step very carefully. So this part is replaced, and y prime is replaced by its equal. All right. And next, negative makes positive. Okay. So I multiply. I can drop the bracket at the parentheses. I got into complex fraction. To take care of this complex fraction, okay, usually we have to do some more algebraic work, which is common denominator is x plus 2y. Okay, so I'm going to take this x plus 2y, multiply the top and the bottom. So multiply by 1. The bottom is going to make the x plus 2y squared to x plus 2y to the power 3. Okay, and x plus 2y multiply 3y, right? So 3y multiply x plus 2y. That's not squared, okay? Because I just multiply x plus 2y to 3y plus 3x multiply 2x plus y, x plus 2y. So these two reduced. So the second term, I would just have 3x multiply 2x plus y. We're closer to the end. We're closer to the end, finally. Now, distribute. Okay, distribute. So here on the first part, we're going to have 3xy plus 6y squared. The next part, we're going to get 6x squared plus 3xy. Okay? This is a great exercise to enhance our algebra skill. So this is 3xy, that makes 6xy, right? I think we cannot reduce, we cannot factor easily. Even if we factor, it's not going to be the same factor as the bottom. The only thing we can do is that we can factor out the 6. That's it. That's all. That's all. Okay? So this is finished. This is finished. The next question I wish to do is that it's actually an odd number because the number 38 is not, is similar to the one we just did. So I thought I would just do the one with trigonometry functions for change. So we have sine y plus cosine x equals to 1. And of course, our target is to find these two. Okay, first order derivative and the second order derivative. Okay, so we just did that. I know, you know what? I think I should summarize it. Okay, the first order derivative, I'm going to give you an explicit answer. Okay, that's the first order derivative. Second order derivative, which is this piece. Oh, never mind, y prime. And this is going to be second order derivative. And that's going to be second order derivative. I'm writing these notations so you guys see them over and over again. Okay. I know you have it, but just for repetition purposes. Okay, second order derivative. So that was a closure of the last question. Forgive me. Okay. Now, second question, okay, on this recording, which is also the last question. We want to find first order derivative. And of course, we're going to differentiate on both sides. Okay, sine y, cosine x, right? All of these. So this piece is differentiated, and derivative on the other side, that's going to be 0, right? This first step usually is not very hard. And on that part, chain rule. Okay, so by this time, I assume everybody is pretty good. Cosine y multiply dy dx, right? Plus the derivative of cosine x is negative. So negative sine x equals 0. Okay, and this one may be unusually easy, but we just do some trig function for a change. Adding sine x on both sides, so we get that. So what's dy dx? Dy dx equals to sine x over cosine y. Sine x over cosine y. And the first order derivative is found. Okay. Guess what? There are some alternatives we can do, because here we have, oh, actually, no, we can't. Sorry, we can't. Okay, so that's it. First order derivative found. Let's find second order derivative. Okay, so second order derivative is the derivative of first order derivative. Okay, all these are different ways to writing them. And there's also y double prime. Okay, so what does that equals to? That equals to derivative of the first order derivative, which is a cosine, which is sine x over cosine y. Okay. Quotient rule. Quotient rule. Quotient rule. So we're gonna have cosine square y, the denominator squared. Numerator, the derivative of sine x is cosine x. And the multiply cosine y. Subtracting sine x stay the same. Multiply cosine y being taken derivative with respect to x. Okay, so we need to use chain rule here. Okay, so don't forget that. Don't forget that. We're taking derivative with respect to x. So for that part, we need to differentiating with respect to x. We introduce chain rule. Of course, we apply chain rule. And now this piece is going to be negative. Okay, I'm writing on the next step. Okay. Whoops. We're writing on the next step. And this part is going to be the derivative of a cosine y, which is going to be negative sine y. Okay, with respect to y. So this piece is right here. Now, let's organize. Oops, whoopsie, sorry. Yeah. Okay. So we're going to organize the term, negative sign, that's a plus. Okay, we can drop the parentheses. Can we combine anything? Cosine x, cosine y plus sine x, sine y, nothing. This time, we're going to replace dy dx by what we just found, okay, which is right here. Boom. Okay. Can we reduce anything here? Can we reduce anything here? Cosine y? No, just sine y, sine x. Cosine x, cosine y. But we can do sine x, sine y over cosine y. And sine x will combine with this other sine x. That's going to be sine square x, right? And sine y over cosine y, that's tangent y. And we're done. We're finished. Okay, surprise, surprise. Okay. So in the end, the second order derivative is, okay, this piece right there. And first order derivative, of course, we have it there. Boom. First order derivative, second order derivative. Well, I think that's all for this recording. Thank you for watching.